Okay, so we're going to go through the worked examples in your textbook, and we're going to start off with the worked example first of all on page 28. So what we've got here is an equilibrium constant at a temperature of 473 Kelvin. So at 473 Kelvin, the equilibrium constant is 8 times 10 to the minus 3 moles per decimeter cubed. And this is for the decomposition of PCl5. So what do we know here, and what are we trying to find out? So what do we know here, and what are we trying to find out? Well, we know that the equilibrium concentration of PCl5 is 5 times 10 to the minus 2. That's something they've told us. What are we trying to find out? Well, we're trying to find out the concentrations of PCl3 and Cl2 at equilibrium. So where can we go from here? Now, we know that every time one molecule of PCl5 breaks down, we get one molecule of PCl3, but we also get one molecule of Cl2. Now, this is the thing that people sometimes find difficult either to understand or to remember, but if we go back to the last video where we introduced equilibrium, we know that every time we start off, it's the other way round here, but every time we start off with one red and one blue, we make one red blue. Or the other way around, if we start off with one of these red blue molecules, it breaks down to make one of each of those. So it is possible to make, in effect, 2 moles from 1 mole of something else. So what we're saying here is that every time we form 1 mole of PCl3, we form 1 mole of Cl2 as well. So that means that our concentrations are going to be equal of the two products here. And so we'll give that a value of x, because we don't know what the actual value is for the moment. Okay, so what do we know, and what are we trying to find out? Well, they've told us that Kc is 8 times 10 to the minus 3. So we know that this value here is 8 times 10 to the minus 3, and we also know from the equation that the equilibrium constant is equal to these two concentrations, the concentrations of the products over the concentration of the reactant. So here's our equation. Now, we said before that we're going to call this concentration x, so all we're doing here is substituting our x's. We've got x times x over the concentration of the PCl5. Now, what do we know and what are we trying to find out? We were told at the beginning that the concentration, the equilibrium concentration of PCl5 is 5 times 10 to the minus 2. Here we are. So therefore we can substitute that into the equation as well. Okay, so we know this is Kc, we know this is the expression for Kc, we've called these two concentrations x, and we know this concentration here. So the next thing we do is just rearrange this. If we're trying to get this in terms of x squared, then we've got to push this 5 times 10 to the minus 2 up here, so we end up with an 8 times 10 to the minus 3 times 5 times 10 to the minus 2 is x squared. Okay, so if x squared is equal to this, so x squared, if we multiply these two together, 40 times 10 to the minus 5. Now that's x squared, so if we want to find out what x is, then we just take the square root of it all, and we find it's 2 times 10 to the minus 2. And we were given a concentration, so it's simply 2 times 10 to the minus 2 moles per decimeter cubed, which is the same as 0.02 moles per decimeter cubed.